Hi everybody. I'm used to being pretty loud without a microphone anyway, so this is going to be pretty raucous. So my name is Paul Ritchie. I've met an awful lot of you today on the floor. Hi. Thanks for coming. The title slide there has the sort of agenda for this talk. Reconnaissance, Post Exploitation, Infil, getting tools into places, and Exfiltration, getting data out, and then a reverse shell. That's what's coming up. That's what's on the menu, guys, right? What this talk isn't really is a talk about Git, although there's a little bit on that in a minute. So first off, I'll say thanks for checking me out, right? So I'm trying to find the level of the room here. People don't want Git-related puns checking me out, no? Wake up. I know you've had lunch. Right. But you had a choice of talks at this moment. You could be at the embedded firmware down there. You could be over at the Insider with Neil Lines. My talk has a little bit of insider threat in there. I don't think his has anything on Git, so you've hedged your bets. What I'm really here to do is to educate and inform and entertain all the way until the cake. Anyone recognize that cake? Points for that one? At the back. It's a lie. I have actually seen the cake. This cake is not a lie, but that's from the game Portal, right? So what we'll do is we'll move on to the next slide, which is the slide about Git. Just for the grounding purposes, all you're really going to need to know about Git for the purposes of this talk are that Git is a version control system, a VCS, for tracking changes in computer files and coordinating work of those files among multiple people. So how do your developer teams develop together? How do they collaborate on the same source code? They need to use a VCS of some sort. Git is one of those. It's an open source project, the Git project, and there you go. And there are alternative VCSs out there like Visual Studio Team Services, Subversion, CVS, lots of those that exist. So what I'm going to say is the techniques that are in this talk are, I believe, transferable to all those different versioning systems. It's just that I had to pick on somebody to make proof of concepts, and why not pick on the biggest bully in the schoolyard, Git, because by any objective measure that I could find, Git is the most popular version control system today. That URL there from 2016 had a whole bunch of different ways of trying to infer what is the most popular version control system, which is actually hard to do because a lot of the VCSs are going to be internal, so you can't really quantify them. So the way that the most interesting statistic I found is that one at the bottom there, that in 2016, more than 20,000 questions were asked on Stack Overflow, everyone's favorite website. 87% of all the questions about version control systems were to do with Git, right? So that's a pretty high stat there. And you can debate them, but it's always going to come out being the most popular. So that's why the techniques that are shown in this talk are relevant to Git. Now, a lot of people are going, is your talk going to be about Git? I was getting lots of people on Twitter basically sending me in their how to use Git guides. Well, I've got all you're going to need to know in a friendly way, designed for the modern audience with an attention span of 18 seconds. Git.
Our whole universe was in a hot, dense state, then nearly 14 billion years ago, expansion started. Wait! The Earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall, we built the pyramids, math, science, history, unraveling the mystery, it all started with a big bang.
Well, thank you very much. I think we found the level of the room. I believe at this point you are now committed to the talk. You now can't leave to go to Neil, and you can't go downstairs because you've bought into that. So you're responsible for the rest of this. So what that was to show is a long route. I'm pretty good at procrastinating. So simply to show that I'm not going to be talking about Git, I have made 25 slides for an alternative play within a play to show you 18 seconds. That's the level of detail we're dealing with here. The play within a play is an entirely different, totally reasonable talk about Git that you can't see and enjoy on full terms, but the people watching at home beyond the fourth wall can pause that and see that there is actually a legit talk on Git, right? Anyway, we don't need to know all that stuff. Those are just commands. It's incredibly complicated. I wouldn't say that I'm actually an expert in how to use Git. I am one of those Stack Overflow question askers. I have to look up pretty much everything. But anyway, not being an expert in it doesn't mean that I can't use it to help me hack stuff, which is the point of the talk. So, using Git for reconnaissance. So, hands up, people that are jobbing pen testers in the room. There's a few of you, right? So, others are just familiar with what a pen testing methodology looks like, right? And for those that are asleep, there's always one, and it's him. Right. So reconnaissance is one of the phases along your penetration testing project. So it occurs at the start of any decent pen test, and it's where you try and learn about targets as quietly as possible to find stuff you can act on. That's roughly my definition of reconnaissance. So you've got 3 topics there, 2 that are pre-existing, and 1 that is a new sort of tool that I'm kind of discussing and releasing today called Git Fingerprint. Git Explorers. So don't go around Googling for the term Explorers and Scrapers. I've just made that up for today, like I'm the king of Git hacking. An Explorer is what I'm going to categorize as a passive form of reconnaissance, so no requests are sent to the target site. It works if you have access to the Git repository, right? So you're able to clone it down. So if you can clone down a repository, you can use an Explorer. It's basically a script that will have regular expressions, things like that. It will rifle through all the files that have been versioned by Git, and it will look through all the commit history in some of the instances, and it'll go through all the branches, and it will try and find sensitive information. That's what an Explorer is going to do for you. So the impact of that would be a loss of confidentiality of sensitive information, like credentials, that kind of stuff, whatever you've uploaded to Git and you didn't really think about it. So to try this out, I made a vulnerable repository. So we have a very simple repository there with a README file, and in the text file you would see an admin and a password, username and password hash, right? Sorry, username and password. So pretty common for people to put default credentials out in that kind of way, so you can see how it might be a problem. So deploy that repository, clone it down, use some of the pre-existing tools. These are GittyLeaks, great name that, I love it, GittyLeaks. Trufflehog, not so keen on that one. GitRob, good name. Just solid name there. So these are the things. They'll have regular expressions. GittyLeaks will be pretty good at finding you passwords. Trufflehog is really good at looking for like AWS keys, PGP keys, looking for API keys generally. So it's pretty good. Next slide will show you a screenshot of how to use GittyLeaks. It's a good simple install if you're using Kali, just a pip install GittyLeaks, and there we go. We got ourselves a username and password. It's managed to find that. Pretty simple, right? You should be doing that on pen test every day of the week if you've got access to a repository. Git Explorers, defending yourself. So don't put sensitive information in a repository that the end put online. Everyone okay? Nobody does that? You wouldn't even dream of it, right? But people do. So the solution that came up online for this was quite simply, if you're going to put a config file in there, use the sort of Linux approach. Make sure that there's a config sample.txt or whatever that ships, but it doesn't have any live config data. It's all commented out. And then, use a git ignore file to essentially make sure that doesn't become part of the repository. That's the sort of workflow that people recommend. But you've got to be aware of that caveat there. These sort of underlines. It says from the man page of git ignore, files already tracked by Git are not affected by the git ignore file. So if you've already added config.txt, it's there, right? So be aware of that. To stop tracking it, you've got to remove it first. Git Explorers, defending yourself part 2. You can use tooling. These 2 tools here, GitHound and Repo Supervisor, are like the inverse of the Explorers. They will use regular expressions and things like that to essentially look for the content before it gets put into a repository or a commit. So it'll give you that little extra hurdle before you're putting it in. So there's for the defenders. Git Scrapers, a form of active reconnaissance. If an Explorer was a passive one, this is active because you're going to be making a couple of requests at least to the target site. It is applicable to use a scraper when the target a site, you don't have access to the repo publicly the same way as you did for an Explorer. You can't just download the repo. But what you have got is a website that somewhere inside the web root, someone has cloned down a repository and you can find the .git folder, right? Because the way that Git works is it needs to index all the files that it's responsible for, that it's managing. So the .git/index file will contain essentially a directory listing of the site. So the pen testers in the room, do you like a directory listing? Right? When you find one of those, aren't you happy? Right? That's what .git/index is going to get you, and you're going to party like it's 1999. It's just, this is it. I now know what all the contents of the web root is. I can enumerate that, I can download that, and freely look for it. So the impact of a scraper is going to be directory listing. So the CWE entry for that is fine. The specific risks and consequences vary depending on which files are listed. So that's a good line there, right? So let's jump on to the making a vulnerable repository for a scraper. So we've added into the same sensitive info another folder, and that folder is called Never Gonna Give You Up, Never Gonna Let You Down, private key.txt, right? So, well, you've just been rickrolled, room. Yeah, indeed. So why has it got such a ridiculous folder name to get there? It's not going to be in your word list unless you're already ricking yourself, right? So if you're going to use derb to try and enumerate content, which is like a good part of your first step of attacking a website, you're not going to have Never Going to Give You Up or Let You Down as a folder name. So you're going to need directory listings most likely to find that. So you make your vulnerable repository, you hide it there, you turn off directory listing in Apache just to make it more realistic. And this is exactly how customers make themselves vulnerable. They CD into the web root, wherever that is. They do git clone, they pull down a repository from public. A little break from the scenario here, I've renamed the folder to admin because it's likely to be in a word list. And then that's us. So we've made ourselves a vulnerable target. Using dirbuster, derb, you will locate /admin, and then you will locate /admin.git, and so you know that it exists. And then you move on to the next one. So what's the problem? The index file isn't a flat text file, it's got a format, and there are loads of tools out there that will parse it, but the one that I like is Gin. So there we go, Gin. You can download the .git/index using wget, that's what the screenshot shows, and then you just use a Gin, pipe it through grep for name, cut, and then you get a nice tasty list of files at the bottom there with Never Gonna Give You Up /let you down private key. What would you do with that, folks? Word list, straight to burp intruder or something like that. Download from the site, use wget, whatever in a loop. That's how you'll use your directory listings. So how would you disable that? First of all, always be aware of what's in the web root. Just because someone doesn't link to it doesn't mean someone will not be trying an infinitely long word list to try and guess it, or there won't be some other future technique like the .git/index file that will let you index it. So number one, defending yourself. First, let's do a little bit of incident response. Not really my area of specialty here, but the find command to find all folders that have got .git in the name within the web root. And then, okay, let's see, did I have any in the first place? Was I even slightly at risk? The next command shows looking at the access log to see if anyone's accessed the .git folder or /index, so you can see did anyone actually practically have it even if it had one, and then fire it over to blocking it. Literally, how do you stop people accessing it? I just used htaccess with a redirect there, a nice 404 solution. It's quite simple. That regular expression will match any request that starts .git and any subfolder or any file in those folders, so it's pretty handy. So we'll test out the defense as well. That's a 404 for admin /.git/index. So even though we know that file is there in our target, you get the 404. You can't now determine its presence based on even a not real URL. You can't get to it. So it's a good solid solution, nice and simple. Right, onto the first new tool, the new technique, Git fingerprint, right? So your problem is, as a pen tester, is that you need to try and find the version of the software that you're targeting, so that you can then look for what was fixed in the most recent version versus the version that your target's running, so that you can then run at your customer and go, I know how many CVEs are running in your environment. I know that there's an exploit, and I know that it works. Phone up the customer, can I run that exploit? I'm pretty sure it's stable. If you're not having those conversations, maybe you've crashed a few more sites in your life than I have. So that's a pen tester specific task, having to figure out the version and then figure out the applicable vulnerabilities and then the exploits. It's, if most of the time these threat actors are probably going to be automated if they're exploiting it, they will just fire it. They will just fire the missile, They don't care. They're already trying to do something illegal. Why would they bother trying to not crash the site at the same time unless they're tasked with being stealthy? But anyway, that's the problem for the pen tester, the jobbing pen tester. Find the version of the target. So it came from when I had to target a site where the site admin had gone through a lot of lockdown steps to remove all the sort of changelog files, the HTML files, the kind of basic things that your standard fingerprinter will sort of go ahead and pull down. So I thought, well, the target's running something that's in a public repository. What if I clone down that repository, use that to generate that word list, similar to the directory listing thing earlier, download from the target site all of the files that I can from the website, and then use a bit of magic to figure out the specific commit of those files in the repository. So this is what we're fingerprinting. It's not the version number. It's not 7.50 of Drupal. It's literally the day that file was committed to the thing, and we can roughly determine from that when the person installed the code in their site. So it works for files which are not altered by the download process. So if you've got a PHP file, it's going to be converted to HTML. It's going to get mangled, right? So you're not going to be able to use that. It has to be SHA hashable, MD5 hashable, identical to the version that was put in the repository. So you're going to need a file like a .js, a .css, or some custom file extension that the application is going to use. So I'm going to shut up for a minute, and then I'm going to talk in a video for you.
Hello, Glasgow BSides. So the thing on the right here, the text editor, is showing the commands that are going to be executed during this this video, showing the run of git fingerprint. If you're watching this video in the future, you should be able to pause that, get these commands, and use them. Whoosh, it's gone. So let's just say our target here today happens to be a Drupal site. Looking at the source, we know that it's running Drupal 7 over here. That's a little breadcrumb that we can use. So the workflow from that point is we would use the git clone command to clone out the branch 7 of Drupal. Here's the folder. We would cd into git fingerprint and launch the interface. It's a Python 3 only script, so Python 3, there we go, a little bit of ASCII art, the hoodie guy. The workflow at this point is suggested by the options here on the initial help. This is a reasonable command line interface. If you type help, you'll have that. It's got tab complete and all kinds of things like that. But anyway, let's stick to our workflow. Set repo path, // tab, we want Drupal. Set target URL, that's the URL that we had in the web browser, 17.0.3. And the next part of our workflow is set files and commit count. So I'll hit that and we'll see what it's going to do. So what it does is it goes into every directory in the repo, it finds every file, and just sort of gets a listing of the contents of the repository. Armed with that, it then uses a git log command to find out how many commits that file has had. The command will take a little while to run here. So what we're going to do is skip to the end. That was a bit scary, wasn't it? The final output of that command is this table over here, which is ordered by the total number of commits. So in the most recent version of the Drupal repository, the most commonly committed file would be common.inc, right? The higher the number of total commits, the more useful it is for fingerprinting a target. So what we're going to do at this point is go back down. We're going to execute the fingerprint version command. And what this does is it for every file in the local repository, it attempts to download that file from the target website, and then it uses a git checkout command to effectively roll back the version in the local repository, and then it will attempt to confirm whether the file that's come down from the target site has been recognized effectively. And when it finds a match, it will then add it to a list of table for the output. This command takes a while, so we're going to skip to the end again. welcome back, time travelers of Glasgow BSides. That command has finished running, so here's the final results table. What we're really interested in when we're fingerprinting a target is the files down at the bottom here, because it's roughly ordered by the timestamp. Not brilliantly ordered, but it's roughly ordered by the timestamp. So we would say our target website has been installed from the code around about October 2016. It's got to have happened after this date. And that's based on the file commit version, which is the sort of number that the target site is running, versus the total number of commits. When it says free of free, that's the oldest version of the file that's possible. When it's 57 out of 831, that's 57 away from being the most recent.
Well, so there's a tool. Right. It can obviously be a bit slicker and quicker than what it's currently doing, but it's at proof of concept stage, really. So what would you do from that point, knowing a date to work from? Because the point is, this isn't just about enumerating Drupal, it's about enumerating a website, arbitrary website that's got the source code in Git, right? So you would check whatever the repository is for some sort of change log, some sort of version string somewhere in there, and then you would look back in the commit history for around about the date that you have, and you've got your answer. That's how you're going to get the fingerprint version. We can't really automate that. In the future, Git fingerprint will probably support you better by just spit me out all the commit log messages nearer than that date, or whatever date you're looking for. And then obviously, if you're really lucky, they're going to be tracking their security vulnerabilities with like CVE references or some sort of custom vendor application specific reference. So if you've got that, you're going to be able to then go, categorically, I've got a pretty good idea that it's vulnerable to these. So it doesn't quite do that yet, but that's where it's going. So to recap there at the end, using Git in this manner, I believe, is a new technique. So we can all enjoy that. And it will work whenever the target site uses version controlled code you can download. The POC, of course, is in Git. We can do it, I believe, for other version control systems, but it's just not implemented. Right? So moving on, using Git for post exploitation. I definitely look like that when I get a shell. It's beautiful, but I must have more. Right? That's what I look like. True facts. Post exploitation, in the line of the pen testing methodology flow we talked about, will occur after you've got a shell on a box. You've got interactive command execution or whatever. You're going to try and gather more information about the target, the data it has, adjacent networks, and you're looking to steal high value information or search for lateral moves, where a lateral move is I'm just going to jump onto this other box because I've got a password or a token or something. So Git has a few options for that. When you're for the budding person who's enjoying his shell, who's looking to take it further, Git uses 3 different kinds of authentication options. Plain text passwords being the top number 1. If you can get a password in the user's home space .git-credentials, because that file is created if some developer goes, I don't want to ever type my password again when I'm making pushes up to the server. That's where it's going to be stored, ~.git-credentials. You can store plain text credentials in that file, and it does, of course, warn you about that in the man page that that's a bad idea. But I imagine some people will be doing it. Plain text passwords and authentication tokens are sort of handled in the same manner. The URL, if the URL has a token in it, that will stand as the username in the logon field. That's how GitHub handles that. Passwords are generally used where the repository is being cloned down over HTTPS, whereas the SSH public key happens where people are doing their upstream pushes over SSH, right? So either of these options will be good lateral movement type things. You're going to have new credentials or tokens to work with. Number 1, password is best, because password would mean I will have the person's GitHub password. I will be able to, or GitLab if it's internal, I will be able to log in, change that, everything about that user's account. I'll have full control of their account. I can see the private repositories, all that sort of stuff. Authentication tokens, I've only looked at GitHub's authentication tokens. They're a bit less valuable. They can be as valuable as the credentials, plain text passwords. But You can also generate the token to have specific privileges. You can say, don't let it access the web interface, don't let it change my avatar. You could literally just say, allow this guy to commit, allow this guy to push, pull, though it's very fine-grained. There's about 100 little checkboxes on the GitHub website for that. So the authentication token, if someone's doing it right, is using it with the least privileges, so it might be a lot less useful than the plain text password. When we're looking for lateral moves, what you've got is remote repository locations. So when you do that git clone command, and you go HTTPS, whatever, and you pull it down, that URL HTTPS becomes the remote location in the local Git repository. So if you then are updating, fetching, pulling, all that kind of stuff that touches the server, it's going to be going over HTTPS. If you clone down over the SSH URL, it will then be making its commits over SSH. So remote repository locations, right? That's going to be stored in the .git/config file. And looking in that file, you'll be able to figure out if it's going over SSH, you'll be able to figure out if it's going over HTTP. And more importantly, looking for a lateral move, you'll be able to tell if it's going to an internal Git server. You've already got a box in their network, but do they store their code in an internal GitLab? Do they put it in a private repository in GitHub? You're going to learn that from looking at the URL, right? So quite useful things if you've compromised the box and you've got a bunch of Git folders to look into. Obviously, you can source code analyze any repositories that you find looking for more vulnerabilities. You can ride the privileges of those tokens and passwords and stuff to poison the repository with malware, and possibly lots more things you can do with it. So to help us out there, I've made my first ever Metasploit module, Git Enum. I love Ruby, everything about it. It will check and dump those authentication options. It will find any .git folders and it will spit out the URL. So not shown underneath it is all the URLs for the repositories. So a little bit of ease towards your post exploitation, help point you towards things that you can play with a little bit. So we'll move on a little bit away from the standard pen testing methodology over to rogue employee scenario. So this is the little snapshot of the insider talk that I imagine is happening downstairs. So lots of customers have had many years of penetration testing now. They know what it's like. Some dude in a suit sits down, hacks a network, load of vulnerabilities. Great. That's totally valid and we're up for it. But increasingly customers have been going, what can a standard user do with their privileges? And I really enjoy these projects. It's a sort of ranging question here. It's like, what can they get onto their workstation? What can they send out of the network? How can they do it? Those questions are kind of fun to answer. So around about 2012, 2013, it was the first time I used GitHub to bypass or at least send stuff in and out through a corporate proxy that was pretty restrictive. The target was a customer that decided to outsource their development out of the country and then fundamentally not trust the people that they've outsourced the development to. So they would operate, imagine trying to develop an application under these conditions. You have to VPN into the external, VPN into only a dev environment. You can't see anything else. You've got an RDP jump box, no copy paste, no roots from basically it just launches Visual Studio and that's all they had. So it's like, but they also, developers do need to update support libraries or whatever GitHub related stuff that they were using. So the corporate proxy through the standard web browser was allowing that out. So I was like, on the day, quick hooky idea, let's just use a Git repository to put tools into the environment to help me enumerate the privileges of the user, and then exfil the data out, obviously with a bit of crypto before I put it up on the internet. So yeah, effectively, the next couple of slides are going to show how to do that just using the web browser. But the impact, I have to say, there's a meme coming up. Bang. I want to stop employees, but I also have to give them the internet. This is a fundamental headache. As a pen tester, I don't generally have to deal with it, but is that anyone's struggle in their day job? Right? There's nodding, there's a hand. That's consensus. It's a problem, right? Absolutely. So I don't envy the people that have to fight that battle, because the second that there's an internet connection, you've given someone an Infil route where they can pull tools in, an Exfil route, and there's no real magic box that can stop that, I don't think, really. But yeah, anywho, infiltration via the web browser. So an attacker can make a repository a bit like this, where I just put some binaries and some word lists in there. That's going to help me enumerate some stuff on the network. Whatever you want. You know, you can hide your tools a little bit. You can use AV bypassing techniques or whatever, but I'm not going to go into them. Pretty simple technique, not using GitHub per se, would be if I want a binary on a machine, I can use base64 to encode the exe, save it as .txt, and then the great tip is certutil, which has been on Windows for a long time, and it's often overlooked but it's got a built-in base64 decoder. So if you want a nice binary over a text connection and you don't want to get caught by a proxy that's blocking .exes, you're welcome. Right? So there's nothing really difficult here. It's just that want to stop employees, but also has to give them access to the internet. And I'm not picking on GitHub for this. I could use a WordPress for this. I could post a comment on a site. If it's allowed through the proxy, I can still do the base64 thing, drag it down, no problem. It's just that a repository has a nice web interface that will allow me to just upload files willy-nilly. So it's quite an easy way to do it, and it just needs to use the browser. Getting tools in, part 2. When you're on the workstation, so I presume you've prepared your repository outside of your place of work. You come in, you can just go straight to the download zip file option now. I do sort of remember when the Git web just allowed me to download individual files, but now it's download zip, which is really much more useful. And that's great because there's no dependency on the workstation. Everyone's got a web browser baked in. It's going through the corporate proxy, all's gold. Getting data out, you can structure that a little bit. You can use the Git web interface to create a folder. I'll save you the Googling. This is how you make a folder in Git web. You go create new file. You start typing something, you type the / and then you create a new temporary file. It shows like AA down at the bottom there. That'll create a new file, but it'll also create a new folder at the same time. Then obviously you can just use the web interface to go file, upload, add to repository. You don't need to keep that AA file now. You've got a nice folder to put your tools in and stuff, or your data back out. So, as we sort of barrel towards the end of the talk, if you've got a route in and you've got a route out, it would be absolutely rude of me not to make a shell. Come back over Git. So, a reverse shell over Git. Go.
Here is a Windows 10 workstation, which is standing in for the workstation of our victim. They operate in an environment where there's a corporate proxy that blocks arbitrary connections to the internet. Although they can see, as part of their day job, they can see anything that's github.com or a few associated domains. Here's a repository that we're going to communicate through in a minute. Here is the Git shell victim executable. Let's run that. What's that going to do? The first thing it does is it clones down the repository here, and then it starts a loop where it's just going to poll and see if there are any new changes, and if it determines there's a change, if there's anything new inside in.txt, it will then just pipe it straight through the command prompt and save the output into out.txt. So the attacker side is over in the Kali virtual machine. Pretty simple. Git shell attacker, pointed to the URL of the repository you're going to use, a location on disk where you're going to clone that down to, and then a GitHub authentication API token. Don't you worry, we're going to scrub. I've already scrubbed that API token. You won't be able to use it. So what have we got? Who am I? Let's just run a Windows command on the victim. It's going to have saved that into in.txt. It's currently uploading it to the repository, and then the victim's checking it out, and bang, there you have an answer. So let's make sure that we're in no doubts that this shell actually operates. So karma labs, fire that into C:\users/users is the user account we've got. Stick it on the desktop so we can see it. Test.txt, and let's see if we can race that. Look, we've beaten it. Way! Pop, pop, pop. Shells through GitHub.
I forgot to warn there was pyrotechnics. That's us, right? A Roundup. We've had a lovely time. It's been fun. Thank you very much. It's been emotional. We used Git for Reconnaissance. We talked a bit about pre-existing techniques, Git Explorers, Git Scrapers. One will find you sensitive information if you can download the repository and you have access to it. Git Scrapers will get you directory listings if someone's made the mistake of downloading a repository, could be a private repository, whatever, into the web root, and then they've deployed that, put it online. Always make sure you know what's in the web root is the answer to that one. Git fingerprinting, a relatively, I think a decent transferable technique for getting a decent guess at what the version is if the admin has done a really good job of locking down the version. Also means that I'm too lazy to start using regexes to pull little nuggets of information to then have a database that stores that this is version X of whatever product and then do that for every product that possibly exists. That sounds like a lot of work, doesn't it? So I don't want to have a massive fingerprint database. What this is a generic way of doing it when maybe there isn't a pre-existing tool for that application. Like, is it DrupScan for Drupal? Did a pretty good job of that Drupal site anyway. So it's not really for Drupal. But if there's a domain where the application is less popular or whatever, using fingerprint can get you a decent answer, right? We've used, we talked about the post shelling sort of options there. You can steal credentials, you can enumerate remotes, you can locate systems that you're going to be able to now influence. So that's what you do post. There's a Metasploit module for that, which is not committed anywhere. At some point, I'll upload that to Metasploit. And then we showed pretty simply just using the web browser in a workstation to pull information through GitHub if you can access it, send it out. And then, yeah, why not a shell and why not some pyrotechnics if you can manage it, right? So, where do we go from here? None of these tools are going to be available right now immediately. They are going to come out of the Sakarma Labs blog. They're going to be visible if you follow us on Sakarma Labs on Twitter. They're going to be coming out over the next couple of months, probably a bit faster, a bit whizzier, a bit nicer looking. So please, follow along and sort of see them as they come out. The next slide is unfortunately the end of our journey. So I don't know if there's a git final command or is that just rm minus rfv. We've killed it, right? Next slide says questions and thanks for having me, right? Questions? No? There's one. I believe that the video goes online in 10 minutes. I think, is that an answer? Will it be available on GitHub? Yes. Because like everything, I put the tools in GitHub/Sakarma Labs. Always pimping that brand. Yeah, so the talk, the slides and actually everything will go online via Sakarma Labs, but I think the video for the talk that you've just seen will mean that you can go back and examine the play within a play and see how I use Git. So it's going online soon. Right? Any more for any more? Nope. Straight on to cake for everybody. Right? Crypto cake downstairs.